Hey chemistry kids, here we go. There's our next installment of the video, the first section of Unit 6, which is going to be the chemical reactions. So here's Unit 6, chemical reactions. We just talked about the major types, or the parts of a chemical reaction, so you know all the vocabulary that goes along with it when you're reading it and looking at it on a worksheet or a book or anything, a test like that. So now we're going to start talking about the 5 major types of a chemical reaction. So here's the first page. Looks like this. It says I can identify the 5 major types of reactions. So the 5 major types of reactions are going to be, first one is called a composition or synthesis reaction. And basically what it is, you're making something, you're putting things together. So a general form, it's going to look something like this. Element A, keyword element, reacts with element B to make compound AB. All right, so now notice how you have parts and you made a compound. So these are going to be just like elements, like could be hydrogen or something like that. You could have 3 parts and they make one thing. You could have 4 parts and they make one thing. All right, but that's the general form. An element reacts with an element to make a compound. So an example of that would look something like this. Let's see here. We'll just do a simple one. Okay, there's a simple one. Element plus an element, or reacts with an element to make a compound. All right, remember a compound is 2 or more elements made together. All right, now remember these are coefficients in the front, these are subscripts on the bottom. All right, but the general form for a synthesis or composition reaction is you have the parts and they make something. Okay, they make one thing. So again, there could be more than 2 things over here. It's possible. So kind of identify what it's going to be looking like. Then the next reaction we're going to talk about is decomposition. So decomposition is the opposite of composition. Composition. All right, so let's flip it around. Now you have the compound and it breaks down into its parts. All right, so like an example of a reaction that would happen, you could say you could electrify plastic current through water and you could break it down into its hydrogen and oxygen counterparts. All right, so now we just switch that reaction around. Here's my compound, here's the parts that it made, so I decomposed it, I broke it down. All right, so look for those for decomposition reaction. You're going to start with one thing, at least in our cases you are, but not all of them do. But in our cases, yeah, you're going to start with a compound and you break it down. So you decompose it, breaking it down. Single replacement reaction looks something like this. You have an element and you have a compound to start with. Those are going to be your reactants. All right, and it could be, the compound could be first and the element could be second. It doesn't matter the order. Reacts to make these. So notice how one of the elements switch spots. All right, so now we made a new compound and a new element. So think a single replacement or displacement, keyword single, that means one. Displacement means it moves. This one moved to this one. All right, so one moves. And always in a single replacement reaction, you're always going to have an element and a compound that reacts. Always. So for example, for this one, you could say something along the lines of, let's say silver reacts with copper oxide. Okay? And what happens is the oxygen will switch spots, so now it's going to be silver oxide, which is going to be Ag. And by the way, this is just a made-up reaction. This isn't a real reaction. Ag2, because remember you have to drop and swap. We'll talk about that in class. And then Cu. So notice how the one switched spots. Basically switch dancing partners. All right. So now a single replacement, 1 switches. All right. In a double replacement, 2 switch. So how it's going to look like this. I have two compounds to start, usually the case, okay, 90% of the time. And now the D and the B switch spots. So two moved around. Okay, double replacement. The B and the D switched partners. So I made two new compounds. So a double replacement, two new compounds right there. And a reaction that could do this would be usually any type of acid-base reaction. Like you could take hydrochloric acid and it reacts with a base. Then you're going to say, oh, I'm going to get HOH and NaCl. There's a double replacement reaction. Compound reacts with a compound to make a new compound and another new compound. That's a double replacement reaction. All right. So look for telltale signs of how it's going to work out. And then the last one we're going to talk about is combustion reaction. Well, what's a combustion reaction? General form, it's going to be usually any amount of hydrocarbon, which means it has carbon and hydrogen in it, and it's going to react with oxygen to make carbon dioxide and H2O. Oops. So this is the general form of combustion reaction. It could be tweaked a little bit, but it's really something reacts with oxygen to make carbon dioxide and water. Those are your telltale signs. All right. So a real example of this would be something like C3H8 reacts with O2, and it's going to make CO2 and H2O. All right, and then if you wanted to balance this out, which we'll talk more about later, it's going to kind of look like this. All right, so there is your combustion reaction. Notice the telltale signs. So here's a little guide on the bottom here that might help you out, but notice how to tell it apart. Synthesis. Parts make a compound. Decomp. Compound breaks into its parts. Single replacement. An element and a compound make a new compound and a new element. Double replacement. Two compounds to start with make two new compounds. And then a combustion reaction can look anything like this. It always reacts with oxygen to make CO2 and H2O. All right, so really what you're looking for when you identify types of reaction is you're looking for key tells to it. Like you should know what a synthesis should look like and a decomposition should look like. And as we in class, we should get more practice with that. So I hope this video helped a little bit. We will talk to you later. Have a good one.